Section 6.7, Roots and Zeros. If you plug this equation into your graphing calculator, you would get a graph that would look like this. You can very easily tell that the zeros of this graph is -3, -2, 1, and 2. The roots are also -3, -2, 1, and 2. The factors are x plus 3 times x plus 2 times x plus 1, x minus 1, and x minus 2. The x-intercepts are -3, 0, -2, 0, 1, 0, and +2, 0. If we had this equation, x squared plus 6x plus 9, and we wanted to find the roots and what type of roots they are, we would factor this out. This is a perfect square trinomial that factors into x plus 3 quantity squared. Do the square root property, and we get, it would be plus or minus 0, but there's no such thing as plus or minus 0. So we just get x equals -3. Or you could have factored into two binomials, put each one equal to 0, and you get the same thing. You get -3 twice. When you get the same variable or the same number twice, that's called a double root. The graph would look something like this, that it only crosses the x-axis one time. To solve this equation, we're going to factor out a GCF. We're going to put the x squared plus 25 equal to 0, do the square root property. So we subtract 25, take the square root. Remember, the square root of a negative number is I, so that's the square root of plus or minus I. Do not forget to do plus or minus I. You have one real and one imaginary number. If we take the square root property of this problem, we get x is equal to plus or minus I square root of 2. And that gives us one real and two imaginary solutions. X squared minus 16, that is a difference of two perfect square. I'm sorry, it's x to the fourth minus 16. You treat an x to the fourth just like if it was x to the second. So your two binomials is x squared plus 4 and x squared minus 4. Now you have two options. You can put each one equal to 0 and do the square root property. And once again, the square root of -4 is plus or minus 2i. So that gives you two reals and two imaginary. Now, another way you could have done this, look at the x squared minus 4. That is a difference of two perfect square. You could have factored this down to x plus 2 times x minus 2, put each one equal to 0, and you get x is equal to -2 and x is equal to +2. You get the same answer, so you could do it either way. If we put this function in the graphing calculator and look at the graph, then you would need to look at the table to find where exactly the x-intercepts are. And the table will show you that the x-intercepts are -2, 0, and -4, 0. So we're going to use the synthetic division to find the rest of our zeros. You can either use -2 or -4 first. It really does not matter. You'll get the same answer. So I'm going to use -2. So using the synthetic division, when you get a zero remainder, you know it is a factor. Now, if I put my x's in, I would get x cubed minus 2x minus 2x squared minus 4x plus 40. Well, I need it, and I'm given another factor of -4, so I'm going to do the synthetic division again. And this time, I'm going to use the 4, the -4. Then I'm given a trinomial x squared minus 6 x plus 10. I can tell by looking at this that this does not factor. This is a trinomial that does not factor. So I have two options. I'm going to put it equal to 0. I have two options. I can either do the complete the square, or I can do the quadratic formula. I am going to complete the square on this one. To complete the square, you get c on the other side. So I have to subtract 10. Remember, you want to take half of b and square it. So half of 6 is 9, half of 6 is 3, squared is 9. So you're going to add 9 to both sides. And the square root of -1 is plus or minus I. Add 3, so the answer is x equals plus or minus 3i. So your zeros are -2, -4, and 3 plus I and 3 minus I. This one we plug into the calculator, and the table does not shows that -2 0, so we're going to use a synthetic substitution or synthetic division. And we get x squared plus 9. We're now going to do the square root property. If you put this function in the calculator, it does not show you any zeros on the table. If you looked at the graph, it's in between a number, so we're not sure. So we're going to have to do another option. My other option is to factor by grouping. So your zeros are 1/3 plus or minus I squared of 3. That is why it did not show up on the table, because on the graphing calculator, when you look at the tables, it only shows the whole number, and that's why 1/3 did not show up on the table, so we had to go a different route. Now the zeros, if we gave you this equation and we told you the roots, we can go backwards and do the polynomial. To do that, you have to put the roots in a factor form. And remember, it's always x minus the root. Multiply these first, the two binomials together, get a trinomial, and then multiply that trinomial times the binomial. This is called the complex conjugate theorem. That means if a plus I is a zero of a polynomial, then a minus bi is also a zero of the function. So they told you that the zeros was -1 and 5 minus I. So you know right away there is a third zero, which is 5 plus I. So we have to put all three zeros in a factor form. And remember, it's always x minus the root. So that's x minus the 5 minus I, and x minus the 5 plus I. I have to do the distributive property. So I end up getting a trinomial. I'm always going to multiply the two factors that have an imaginary number together, because some things might cancel out. And notice that the xi's canceled out and the 5i's canceled out. And don't forget that I squared is -1. This is a polynomial function. You could check this by plugging in the calculator The only zero you will see on the calculator is -1. Here's another example. Notice that they only gave you 2 zeros, but we know the third one by doing the conjugate. The conjugate would be 1 minus 2i. Put these in factor form. Distribute your negatives. I'm going to multiply the two trinomials together that have imaginary numbers because I'm hoping that things will go away. Which they do. Don't forget, when you see I squared, that's -1. Okay, look at this page that tells you what's happening for the next couple of days. Be sure to come in for tutorials.